Well, this video is for Math 60, and this is sort of the first video that we're going to get into some real algebra. Okay. Some of the stuff we've been doing for the past week kind of leads up to algebra, those issues having to do with positive and negative numbers and the order of operations, and we did some substituting. So we have worked with variables before, okay? And that's sort of the, one of the main ideas of algebra is working with variables. And in many ways, algebra is a series of processes to do arithmetic to variables. And we'll start that with this assignment on combining like terms, and then we'll continue with that. Algebra itself is thousands of years old. Chinese mathematicians, Egyptian and Babylonian mathematicians all used algebraic processes as a way to think about unknown quantities, about things that they wanted to know they would represent in some way. Our system of using letters to represent these unknowns comes from Europe. Previous to that, people just kind of wrote about the quantity that they were interested in. Let's see here. Now, algebra itself, well, in many ways, people often say that mathematics is the language of science, because science, then the scientific method, typically involve measurements. Okay? And so, describing the calculations and the relationships between those measurements usually involves mathematics. And algebra is the grammar of mathematics. Okay? In the same way that it's a lot easier to understand someone if they're using proper grammar, generally. Okay? It's a lot easier to understand mathematics if you understand the processes of algebra. And even if you're not interested in the sciences, all disciplines really can benefit from an understanding, a general understanding of algebra. Something that happens frequently is people use spreadsheets, okay, an Excel spreadsheet or whatever version of it you're using. Spreadsheets are very, very common all throughout our society. And these spreadsheets typically involve the use of algebra. I remember talking with a friend of mine once and telling him about this, and he said, no, I don't use any algebra. And I said, do you ever make a spreadsheet? And he goes, well, my assistant does that. And I said, well, somebody's doing it, okay? I'm just saying, it's important, all right? And if you can somehow get out of doing it, well, then fine. But what I'm trying to communicate here is that these ideas are important. Okay, so let's take a look at some of the problems from the assignment. And the idea here is that we want to combine like terms. Okay, we're using letters to represent unknown quantities. And as these unknown quantities interact with each other, we can make calculations even if we don't know the value of the unknown quantity. So for example, problem 2 says 5a plus a. All right, so let's talk about some fundamental ideas. Okay, when we say 5a, in the same way that when we were talking about order of operations, I talked about how 5 times 3 means 3 added to itself 5 times. Okay? Same thing is true of 5a. 5a means a added to itself 5 times. All right? And this a itself over here by itself, this is just, how many a's are here? Well, 1, right? This is 1a. So if we have 5 a's and we add 1a onto it, we're going to end up with 6 of them. We're going to end up with 6a. Okay? And that's the fundamental idea behind this concept of combining like terms. Okay, well, let's keep moving here. Problem 4, negative 3y plus y. Okay. Well, this negative 3y says that we have 3 copies of negative y, right? Negative 3y is negative y, and negative y, and that's negative 3y. If we add on 1 positive y, well, these two are going to cancel each other out. We're going to end up with negative 2y. And you can, I'm just showing you these ideas to try to help this make more sense. Really, all we're doing is going 5 and 1 is 6. Negative 3 plus 1 is negative 2. And make sure that we include the variable along with that. Okay. All right. Let's see here. Problem 6. Problem 6. X minus 4y. Okay. Well, when we're adding things together, like let's say we have, 2x plus 3x equals 5x. Doesn't matter what x is, whether we know what x is or we don't know what it is. What we can say is that if we have 2 of them and we add 3 more on, we'll have 5 of them. Okay, so that's that process of doing arithmetic to the variables that I said that algebra it makes up a large part of what we're doing in algebra. Now here we've got a 1x and here we've got a negative 4y, but we don't know what x and y are. They're not the same thing, so there's not much that we can do to this. This is the simplest form. We just leave it alone. Okay? And that's why this is called combining like terms. These are like terms because they both involve the same variable raised to the same power. Okay? Over here, these are not like terms, and so we can't combine them. All right. So now in problem 8, we've got 5ab minus 12ab. Okay. So we don't know what a and b are, okay? But this quantity ab involves them being multiplied together. Now once we do that, we can consider that as a particular quantity. And this is saying we have 5 of those and we're subtracting 12 of them, and that'll leave us with negative 7ab. And so when we're talking about like terms, they have to have the same exact variables raised to the same power. So for instance, we'll see this in later problems. X squared and x are not like terms, okay? Because they have different exponents, right? If x were 7, this would be 7, and this would be 49. That's why we don't add them together, okay? All right, let's keep going here. Now in problem 10, we've got negative 5x squared plus 3x squared. Okay, got the same variable raised to the same power, so these are like terms. Negative 5 plus 3 is negative 2x squared. Okay, let's see here. Well, let's look at number 12. We've got negative 3a minus 4a plus 1a. So this is negative 7a plus 1 makes negative 6a. And let's look down at problem 16. Negative 7n plus 4 plus n. Okay, well, the 4 is not a like term. We can't add it to the n's, okay? It doesn't have an n, and so it's going to stay on its own. This is going to be negative 7n plus 1n makes negative 6n plus the 4. Still stays with it. But we don't combine them together. Okay, problem 18 is very similar to that. We've got 2y plus 7y minus 1. And And so we'll add the y's together. 2 and 7 make 9 y's. And then keep the negative 1 there. Okay, number 20. Now we start getting into the ones that are a little bit more interesting. A little bit more going on here. Okay, so here's the thing. With problem 20, we want to identify our like terms. We've got AB's, and then we've also got an A and a B. And those are 3 different things, right? If this is 3 and this is 5, these will be 15s. So these are the same. These are different from each other. They're also different from these, okay? So this and this together, -2 and +1, will make -1 AB. You can just call it negative AB if you want. And these just stay the way they are. There's not a whole lot that we can do with them. And so there's our answer in simplified form. Okay, let's see here, 22. And this one, problem 22, is I think very similar to what you'll see on the quiz. Okay, so again, we want to identify our like terms. We've got x's here and here. 20x and 2x makes 22x. And then we've got the constants, okay, or the numbers without variables here and here. -15 and +9, and so that should make -6, and there's our answer, 22x minus 6. Now again, just like when we were doing order of operations, don't fall into this trap where you go 20x minus 2x. That's not how it works. This minus sign is attached to that 15, right? The sign for each of these terms is always in front of it. And you can move them around however you want. You can calculate adding and subtracting whatever order you want, so long as you keep the sign for each term that's in front of it. Okay? All right. Well, let's keep going with these. Problem 24. We've got 35x minus 6 minus 4x plus 2. Okay, so this is very similar to this problem. There's our x's, and then we've also got our constant terms, right? So 35x minus 4x, 31x. -6 and +2 make -40. And there we go. All right, 2 more problems here. 26. And again, I think that you'll see problems very similar to 26 and 28 on the quiz. 6, 3y minus 2y. Okay, so now we've got 3 types of terms here. All right, we've got the x's. Oh, I want to include that negative there. There's the x's. Here's a y, and here's a y, and then we've got the constant terms there and there. And this is a habit I got into when I was doing, once you get past these beginning ideas of algebra, this type of process shows up the further you go in mathematics, and occasionally you end up with these long strings of terms, right? And so this is a habit I got into when I was younger to try to identify all the like terms. I'd go through them, and put circles or squares or triangles or underline. And sometimes it can help you visually to see what's happening. So here and here, we've got 8x minus 5x. That'll give us positive 3x. Let's see. The 3y minus 2y, that'll be positive 1y. And you can put the 1 in there or not. It doesn't, it's right either way. And then a positive 6 minus 4, that'll give us positive 2. And this is kind of standard form, is to put the variables first and the constant terms last. But, you know, it's not going to be wrong if you write it any of these ways. Okay, these are all correct. And the quiz, when you do the online quizzes, that computer setup is programmed to recognize all of these as being correct. Okay, let's look at one more here. Problem 28. So, got 16 minus 4x plus 7x squared minus 12 plus 9x minus 4x squared. Okay. So, remember the x squareds and the x's are different. So this and this are like terms, but this and this are like terms with each other, but they're different from the x squareds. And then we've got the constant pieces here and here. Okay, so the x squared terms, you've got a 7x squared and a minus 4x squared. That makes 3x squared. Here you've got 9x minus 4x. That'll be 5x. And then 16 minus 12 is 4. Now, when you're writing something that only has one variable but has different powers of that variable, what's called standard form says to put the highest exponent of that variable first and then progressively lower ones until you get down to the constant term. And again, when it comes to doing the quiz, we're taking a test, you know, well, any of these are correct. If you put these in a different order, I will still mark it as correct. Okay, you may run into instructors. Different instructors have different preferences. At this point, I don't really care whether you follow this standard notation or not. I want to make sure that you can combine the like terms first, okay? And then we can worry about standard form later on. But what I'm saying is that you may run into an instructor who is very focused on standard form and will mark this one wrong, but I won't, okay? So that's just sort of a personality issue that comes with any sort of educational environment. Okay, so that's it for combining like terms. As always, if you have any questions, please let me know. Thanks.